So, welcome back, and we are going to review a little about the different forms of equations that we've been doing, like slope-intercept form, standard form, and graphing them. So we are going to have some homework today, classwork / homework. Some of us will finish it in class. And the homework is just going to be graphing, and it's going to be focusing in on slope-intercept form. So let's graph both of these on this one graph right here. You guys don't have graph paper, so just do a quick sketch. This first one says graph y equals 3 over 2x minus 1. And if you remember, the slope is 3 over 2, and that tells you your steepness. And the negative 1 is the intercept, the y-intercept, not the x-intercept. So we begin by going to the y-intercept value, the b value of negative 1. So you go to your y-axis and you go to negative 1 and you put a dot right there. Now from that dot, you have to rise and run according to your slope. And it says rise 3, run 2. And we'll review this in a bit in case you feel a little rusty. So we're going to rise 3, 1, 2, 3, run 2, 1, 2, and we put a dot right there. And that's our line right there. All you have to do is connect the dots, put some arrows on it, and if you wanted to make the line longer, you could continue with that pattern of up 3 over 2 and go up 1, 2, 3 and over 2 again and put a dot right there. Or you could go backwards, over 2, down 3, over 2, down 3, over 2, down 1, 2, 3, put a dot there. But that's already a good enough line. Anyway, it's really easy. It's the easiest to graph with y equals mx plus b. Now, if we look at number 2, that's not in y equals mx plus b form. What is that? What form is it in? Anybody? ax plus by equals c. That's called standard form. And standard form is great to find x and y intercepts. So on number 2, you could get y by itself by adding 3x, dividing everything by 2, change it to y equals mx plus b, then you graph it the same way you did above. Or just for the sake of reviewing, we could find the x-intercept and the y-intercept. Okay? And to find the x-intercept, we have to set the y equal to 0, and that's something you need to know. And to find the y-intercept, you set x equal to 0. Again, something we need to know. So when I take the above equation and we set y equal to 0, here's y. I'm going to put a 0 right there. So again, I just rewrite it and I actually plug in a 0 right there where the y is at. Okay? So when I do this work, it's really easy because 2 times 0, this guy just disappears. So you could just scratch it out if you want, but the bottom line is your new equation is negative 3x equals 6. And how do you solve that? You divide by negative 3, divide by negative 3. So you get your answer. Your x-intercept is negative 2. So that's your x-intercept value. That tells you where it's going to cross the y-axis. So let's find the y-intercept now. Again, for the y-intercept, you're going to set x equal to 0. Here's x. Let me rewrite this whole thing, but put a 0 right here in place of x. So as you can see, instead of negative 3x, I put negative 3 times 0. And of course, what that does is it just makes it disappear. So it's not there anymore. I could scratch it out, but rewrite it. 2y equals 6. And to solve this equation, you simply divide by 2. Divide by 2, and you get your answer, y equals 3. And that is your y-intercept. So you know where it crosses your x. You know where it crosses your y. That technically gives you 2 points. And that's all you really need to graph an equation. To graph a line, you need 2 points. And we have that. So let's go to the graph. And let's go to negative 2 on the x and positive 3 on the y. And if you graph those two, or if you connect the dots on those two, you have the line. So this one was number 2. This one was number 1, equation 1, equation 2. So I hope this is all very familiar to you guys. I hope you guys understand this. You remember this from before Thanksgiving break. Let's take a look at a different question here. Let's look at question 3. Why do we graph equations? Anybody remember why we graph equations? Why do we graph equations? Anybody? Well, we graph equations and they become lines. And okay, I'll give you a little hint. Why do we put arrows on them? Because it continues forever, right? So what does the line actually represent, Caden? It represents every single solution that exists to an equation. So when we graph, why do we graph? To represent the infinite amount of answers that exist to an equation, right? That's why we graph. So let's go back and review both forms. Or how about this? Question 4. What forms of linear equations do we have covered so far in this class? You guys remember the names? Slope-intercept form, that's a y equals mx plus b. And that's technically number 1 right there. How about what other form have we covered in this class? Standard form, and that's technically number 2 right there. Ax plus by equals c. And technically we've also done function form, right? Where you just get y by itself, and it's nice to be able to plug in some inputs and pull out some outputs. So let's actually go back and review the notes for slope-intercept form and standard form. So slope-intercept form is y equals mx plus b, all right? The m's in blue. What does the m represent? Slope. Rise over run, okay? So yeah, it's slope-intercept form. Why? Because if it's in this form, remember form is just the way it's organized. If you have y by itself equals a number x plus a number or minus a number, then you'll be able to see your slope and you'll be able to see your intercept, specifically the y-intercept, not the x-intercept, okay? So anyways, the m value is rise over run. Even if they don't give it to you as a fraction, even if they say like y equals 3x, you don't just want to say 3, you want to say 3 over 1, because that tells you how much you rise and how much you run. Now there's a couple of important things about m. Obviously it's a fraction. The numerator is the rise. And the rise could be positive if it's going up, that's why I put a plus up here, or it could be negative if it's going down. That's why I put a minus down here. Okay? But the run, we're always going to look at the run from left to right. Kind of like we read a sentence right here, it says slope, intercept, form. You don't read it backwards and say form, intercept, slope. You go from left to right. So we're going to look at lines from left to right, kind of like we read sentences. Okay? So m is slope, that tells you your steepness. And what is m really? It's a fraction. Even if it's not a fraction, make it look like a fraction. That way you could clearly see your rise or your drop over your run, always from left to right. So if we think about what rise is, what is rise really? Rise is the change in y. Okay, rise is the change in y. Because on an xy plane, your y value is going up and down. And the run, so let me get this out of the way. So the rise is the change in y. The run is the change in x. Okay? So when we think about the change in y, that's really the difference in the y values. And we're talking about difference in y values, that's really specifically y2 minus y1 over x2 minus x1. So that's what slope is. It's rise over run. Let me put a fraction bar here. Rise over run. And what is rise really? Rise is really the change in the y's. That's where this comes from on the slope formula, y2 minus y1. The run is really the change in x's, x2 minus x1. So I hope this helps you refresh on what slope is. It's a steepness, and even remind you of the slope formula, which we have to have memorized, and we will be using in the next weeks. Anyways, the b value is what? What's the b value? What's the b value? Anybody? The y-intercept, that's right. The b value is the y-intercept. And what does that mean? It's where your line crosses the y-axis, specifically the y, not the x. Okay? So, as we did on the class opener, if you know your b value and you know your y and you know your m value, well, you go to your b value, put a dot right there, and then you rise and run according to your slope. So I think we have a good understanding of that. Let's go to standard form now. Standard form is capital AX plus capital BY equals capital C. And they're capitalized to help you remember that A, B, and C are just numbers. integers to be more specific. And integers are positive or negative numbers, but no fractions or decimals. Okay, so A, B, and C are just numbers, number, no fraction, no decimals. On a multiple choice test, you might always see the A value as positive, right? So if you had a standard form equation that said negative 3x plus something else minus something, you would have to change that negative 3 to a positive 3 by multiplying everything by negative 1. Okay. So slope-intercept form was great for graphing. Standard form is great for what? Anybody? It's great for finding x and y intercepts, right? So if it's in standard form, kind of like number 2 on the class opener, if it's in standard form, it's really easy to find the x-intercept, the y-intercept, and then you could graph your line. But the quickest way to graph is slope-intercept form. But if it is in standard form, this is pretty quick. Okay, so I hope this helps as a review. We will be graphing in class and for homework today, but mainly on slope-intercept form equations, not standard form equations.